Good afternoon, everyone. Welcome to today's webinar. Very proudly brought to you by the ARB Group. My name is Angela and I will be your moderator today. I'm very pleased to introduce today's presenter, whom many of you already know. Anthony Germanchev is the team leader for the Freight and Heavy Vehicles team here at ARB Group and is indeed a very well-regarded industry professional. Thank you, Anthony, for your time today. The webinar is entitled Modular B-triples, Next Generation High Productivity Freight Vehicles, and is based on a presentation given by Anthony at the 25th ARB conference held in Perth last year. Before I hand over to Anthony to begin his presentation, I'll just run through a few housekeeping matters with you. Today's webinar will be approximately 40 minutes in duration, and we've allowed about 20 minutes for question time at the end. Now, that doesn't mean wait until the end to ask your questions. Please keep them coming throughout the presentation, and we will endeavour to answer them either during or after the presentation. We're also recording today's webinar, so a link to the recording will be sent to all of yourselves once the webinar has concluded, and we will also be sending you a PDF version of the presentation material. So don't worry too much about taking notes. We'll have all that sent to you shortly thereafter. Now, just a few functions of the GoToWebinar system for those of you who haven't used the system before. This is where we ask you to type your questions for the presenter, so just type away and hit send and that will come through at our end. But as I said, please don't wait until the end to ask your questions. Keep them coming and we'll answer them as we go. The presenter may also ask you to raise your hand to one of his questions, and if he does ask you to do so, it's the icon here that we have an arrow pointing to now. So it's just a matter of clicking that when the answer applies to you. And without any further ado, I will hand over to Anthony to commence his presentation. And once again, thank you all for joining us today.
Thank you, Angela, and hello everybody and welcome to the webinar. As Angela said in her introduction, my name is Anthony Germanchev. I'm looking after the Heavy Vehicles team at ARB Group. The team at ARB is a team of 7 engineers. We have 6 mechanical engineers and a civil engineer, and we're also supported by staff in our regional offices in the Brisbane, Sydney and Perth offices. The work that the Heavy Vehicles team does is really centred around vehicles like the one that you see on your screen now, which we've labelled the next generation of freight vehicles. It's a B-triple, and the aim of the team really is to move freight more efficiently, and this vehicle is good at achieving that. We're not transport operators though, so we're not moving the freight ourselves, but we provide the engineering services to make that happen. And the engineering services are really, well, the examples of that are really showcased in a project called Modular B-triples, and that's the subject of today's webinar. Now, the webinar will become technical. We'll go into the details of the vehicle's performance, but we'll start simply, and we'll start with just these 2 pictures here of a B-double and a B-triple. Now, I've circled the B's here, and I'll get to that later with our first poll that will come up shortly. But the double and the triple concept really requires no explanation. Now, here we have conventional articulated vehicles, semi-trailer, an A-double road train and an A-triple road train. Now, these are the workhorses of the Australian freight industry and have been for a long time, but the difference is the A and the B, so that's where I'll ask my first question. So we'll open the poll, and Angela, you can join in here to explain how that's done, but I will pose a question to you. And the question is, you should be able to see that on your screen. What does the A refer to? Does it refer to articulated A-type couplings, or the A has no particular meaning?
Thanks, Anthony. I'll just, for those of you who haven't used the GoToWebinar system before, you'll see a pop-up box on your screen, as Anthony explained, and it's just a matter of selecting whichever answer choice is your answer and clicking submit, and that will come through at our end. So we'll leave that open for just a few more seconds while a few more people get their votes in. I can see We're almost there. 82% of people have voted. And I might just close that off now and I'll be sharing those results with you. So those are the results. Anthony, can you see those on your screen over there?
I can.
Okay.
It looks like we have a very learned audience with 77% saying A-type couplings, which is the correct answer. I thought a few more people would say articulated because it does make sense that the A would represent articulated, but all those vehicles, both vehicles that have A and B type couplings, are articulated. But the A in A double road train and A triple road train refers to the A type coupling, and the B double and the B triple have B couplings. Now, the next slide will explain that.
Fabulous. I'll just close that poll off and let you get back to it. Great.
Thanks, Angela. Okay, so now we can see what I mean when I refer to an A-type coupling. So an A-type coupling comprises of a pin coupling that then connects via a drawbar to a converter dolly, and then that is connected to the following trailer. And down the bottom of the screen you can see a typical B-type coupling, which is just simply one coupling connecting the two trailers, and that is also referred to as a fifth wheel. Now here are some photographs of A-type couplings. So you can see that there is a pin here and then a drawbar eye, and the drawbar eye goes through the pin and it allows rotation in the yaw and sway direction, so it allows the vehicle to articulate around that point. Now that is good for manoeuvrability, for vehicles to access tight turns and negotiate through intersections, but it can cause swaying movements at high speed in a straight line. Now the B-type coupling, you can see that's what we refer to as a fifth wheel. You can see a plate there. It also has a central point there with the jaw in the middle, and the pin is on the following trailer and it goes inside that jaw, as illustrated there by the arrows. Now the main difference between the B-type and the A-type coupling is really that skid plate, those black surfaces that you can see on the left diagram, and that provides roll coupling between the two units. So previously in the pin-type coupling, the two units can roll independently of each other, but with this type of coupling, if the rear trailer was to start to roll, it would be coupled to the front trailer or the leading prime mover, and they would roll together, and that's what's referred to as roll coupling. And that's a very important distinction between the two types. And a roll coupled unit can be more stable at high speed and traveling in a straight line, but because it has one less articulation point as part of the coupling, it doesn't maneuver at low speeds through tight intersections quite as well. So I wanted to explain those fundamental principles of these couplings is very important for the work that we'll go through later. As you can see, B-triples have two B couplings, and it's very important for how they perform. Now the naming convention, it's also something that people might not be aware of, but the A and B type couplings are used in naming road trains. So when you get to 3 or 4 trailers, you would use the couplings to name that combination. So here we have a B type coupling followed by an A type coupling and then another A type coupling. So we would refer to this as an BAA quad road train. Whereas in this example, the first coupling is an A-type coupling, followed by another A-type coupling, followed by a B. So it's an AAB quad road train. So if you've ever heard those terms used before, now you understand where they come from. And you can use that to piece together any kind of combination. Another more common combination than the quads that you see here is a 3-trailer combination, which is the AB triple, which would be the same vehicle as you see in the bottom of your screen, but without that second A trailer. So it would be an AB triple because it has 3 trailers in total. Okay, now there's the background that you need to know about coupling types for A and B combinations. The project itself, the Modular B-triples project, the objective was to develop a national policy for B-triple vehicles, and in doing so develop a prescriptive modular B-triple combination. And that B-triple combination needed to be suitable for an existing road train network, the A-double road train network. That was the aim of the project. Modular is a word that probably needs a little bit of description there, so that's what's shown on this slide, where we have a legal B-double And by adding another lead trailer, you can form a B-triple. And you can put that in any configuration. You can put that lead trailer first or second in the combination, and the B-triple would be compliant with regulations. So it would be modular, and it would also be able to be built from existing equipment. So that's what the word modular refers to in this context. And now it's true that B-triples are widely used in several jurisdictions prior to the Modular B-triple project. That's WA and NT in Queensland. But in other states, they were restricted to limited networks, particularly in South Australia and New South Wales. So the idea was to use this Modular B-triple combination and match it with the A-double network, which is a well-established existing road network. And that would unlock a lot of productivity for the freight industry. The other word that I used there as part of modular B-triples was prescriptive modular B-triples. Now there are a few options that the project could have taken in coming up with a design, a B-triple design that the industry could utilize. And one would have been a blueprint design that specifies all the components of the vehicle, its dimensions, and then hands that over to industry to operate. Another approach could be utilizing the performance-based standards scheme. Now, without spending too much time describing what performance-based standards is, you can deduce that from the name itself that it gives access to vehicles based on how they perform rather than how they look. Now, B-triple operators still have that at their disposal. They can organise a PBS assessment, have their vehicle one by one, each one individually assessed, and if they pass a certain set of standards, they can get access to the road network. But the path that the project did take was to come up with a prescriptive design based on the PBS methodology, so that transport operators didn't have to do one by one individual assessments of every single combination out there, but the project itself would run a bulk set of assessments and then come up with a prescriptive design which wasn't restrictive at all, and you could operate B-triples using existing equipment. So the methodology for making that happen was to use the PBS standards as the benchmark, but then also compare the performance of these B-triples against reference A-doubles that are already using the network that we're targeting, to also compare against reference 36.5 metre long B-triples, because you can have 36.5 metre long B-triples, but also B-triples that are slightly shorter at 35 metres, which were the modular concepts. I'll explain that a little bit more in more detail later. And then also to compare against the PBS Level 3 standards, which are basically equivalent to the A-double road train network. We also didn't want to exclude any particular operator from this opportunity, so we assessed different types of freight categories. High and low density bulk freight, which would include grain and sand and soil, general freight, which is basically a palletized load, refrigerated vehicles, livestock vehicles, and tankers.
Sorry, Anthony, I might just sorry to cut you off before you go on to your next slide. We've had a few questions relating to whether the webinar is being recorded, so I'd just like to reiterate at this stage that yes, we are recording the webinar, and everyone here today will be sent a link to the recording so you can watch it again at your own leisure, and we will also be sending a PDF version of the presentation materials, so look forward to receiving those on your email within the day. Thanks.
Very good, thanks Angela. I was going to pause at this point anyway and take any other questions. So I think the mode for questions, everyone is muted there, so I can't hear you, but you can type your questions into the dialog box and I'll see those and be able to answer them. So just pausing at this moment for questions. The photograph that you see on the screen is actually the first B-triple vehicle that was assessed against the PBS scheme. So it's a vehicle that had access to the road network prior to the Modular B-triple project. It was commissioned by DECA, which is a driver education centre of Australia, and ARB did the PBS assessment and it has access now. It was requested for driver training purposes, and this photograph here was taken during a testing project, and we're actually looking at the braking performance of these vehicles.
Fabulous stuff. Well, Don't forget everybody, webinars are more enjoyable if they're interactive, so please don't be shy in getting your questions through. There's no such thing as a silly question, so we'll happily address those as we go. All right, so Anthony, I have a question that's come through from Tom. Thank you very much, Tom, for your question. He says, I assume the logging vehicles would be acceptable.
The logging vehicles were not included as one of the freight types. So the closest matching freight type would probably be general freight. So you could get, if the vehicle doesn't exceed the height restrictions, there's no reason why you couldn't operate a logging vehicle under this scheme, under the conditions that apply to general freight vehicles. I can also see a few more questions coming up, which is great.
Yep, so we've got one from David, and more of a comment. Need to also point out NTC work with you guys also used D-double as a comparison vehicle.
I think that would be B-double, but yes, that's worth pointing out as well.
Sorry. Alrighty.
And there's a question there I can see also about the general freight. There are a lot of questions coming through, which is fantastic. Did we assume them to be curtain side or flat top trailers? The general freight category was based on the overall height of the vehicle to be limited to 4.3 metres, and then to have palletized loads. So the payload for a palletized load was assumed to take up 40%, or the CAG to be positioned at 40% of the available payload space. So that does not restrict curtain siders or flat top trailers at all. It just provides quite a conservative assumption over the type of payload that would be carried by a general freight vehicle. And remember, all of these comparisons were relative, so we were comparing a general freight B-triple versus a general freight A-double or B-double or B-triple. So they were compared like for like, and that way it was a fair comparison. And David just confirmed that he was referring to a B-double, not a D-double, which would be a new concept. Maybe the ATA are working on.
Anthony, we might just take one more question then before we move on. And don't forget, ladies and gentlemen, if we don't get to your questions during the webinar today, we'll more than happily chat with you after the webinar. You can contact Anthony at any stage. So the next question is from Vincent. Thank you, Vincent. How do Modular B-triples compare to PBS A-doubles and Super B-doubles in terms of safety and performance?
Well, that's the subject of the next part of the presentation, so I'll answer those questions as we go along, but very good question.
Excellent. Alrighty. Did we want to move on, Anthony?
Yeah, I think I've got one more question there from John. I'll just answer that as we move on. I probably did answer that previously about the differences between flat tops and curtain siders having different roll resistance or any other different characteristics. And the idea was to have like-for-like comparisons, so whatever we were assuming for as representative of a curtain sider, or in this case a general freight vehicle to cover both categories, that would be compared against the equivalent set of assumptions for the A-double. So it would be a like-for-like comparison.
Excellent.
So,
thanks for getting to all of those questions, Anthony, and everyone, keep them coming. Anthony, back to you.
Thanks, Angela. Okay, so here are the list of vehicles that we assessed, a total of 210 vehicles that would represent the vehicles out there that would be operating under this scheme, hopefully in the future. 162 of those were modular B-triple combinations. 24 were reference B-triples up to that 36.5 metre length, and 24 were reference A-doubles. And the diagram there you can see that within those 162 and 24 categories, there was a range of dimensions, different fifth wheel leads, different front overhangs, rear overhangs, and so on, as well as different freight types. Now, in answering Vincent's question, how do they compare? We compared them using the key measures from performance-based standards. All 16 safety standards were assessed, including the 4 infrastructure standards. But the ones that I'm going to present here in this webinar are tracking ability on a straight path, low-speed swept path, and static rollover threshold. 3 quite important measures. So to explain which one tracking ability on a straight path is, It's pretty much, again, as the name suggests, the vehicle's ability to track in a straight line, but on a rough road with crossfall, probably what the vehicle would be doing the majority of its time. And while doing that, the vehicle, the driver is trying to follow a straight path, but there's undulations in the road surface that cause the vehicle to sway, and the vehicle ends up taking a wider path than just its maximum width of 2.5 meters. And that's illustrated here in this top view. This is an output of one of our simulations, and all those blue wiggly lines that you see on the screen represent the corners of all the vehicle units on the left side of the vehicle and also on the right. So you can see the green arrow showing the direction of travel. To measure task, you measure the extreme points of both the left and right side and take a measurement, and in this case the example shows 2.95 meters. So that would be how much road space the vehicle will require. And here are the results for the Modular B-triple project. Now we have 6 sets of beautiful rainbow coloured bar charts, each representing the different freight types. So the first one on the left is low density bulk. So a reminder there, low density bulk products would be grain, and then the next one is high density bulk, which would represent something like sand or gravel, and then we move to general freight, refrigerated freight, livestock, and tankers. And on this chart we want the shortest bar charts possible, because the higher the bar chart, the more road space required. And we want them all to be less than about 3 meters, which they all are. You can see that the task measurement is on the y-axis there. They're all below 3 meters. The shortest are the tankers, which is interesting. That would probably be due to having a low center of gravity and being very stable on the road. And now the black lines that hover above represent the reference A doubles, the reference road trains. So you can see, if you can compare all the vehicles, all the color charts represent B triples. So they're all better, apart for one, than the A double counterparts in each of their categories. The one vehicle, the one black line that is above, is in the high density bulk category, and that's actually the black lines that represent the reference B triples, so the B triples that are 36.5 meters in length. And you can see in all cases that the 36.5 meter B triple is has the highest bar chart, so it's the worst performing out of all the other categories. And the different colors in each of these rainbow charts represents different dimensions. As I said, we had different fifth wheels, different front overhangs, so you can see that each color represents different internal dimensions. Now, we're showing there that B-triples perform quite well at high speed when traveling in a straight line. The majority of the time is spent doing this, but they do need to turn corners eventually. So low speed swept path is the measure that looks at their ability to do this. And the actual measure that we report is the maximum swept width, the maximum space that the vehicle takes up while turning on a tight turn. Here's a photograph taken during a trial that was done up at Dubbo. The vehicle is turning on a tight radius turn, and you can see the RTA and RMS guys there making some measurements. All the work that ARB did was based on vehicle simulation, so we simulated the performance. Our models are validated against field data and test results, but simulation allows you to run, you saw how many vehicles we were assessing, allows you to run bulk simulations in a much shorter period of time than doing any tests, and it also removes the error, the measurement error. As you can see, it can be quite difficult to measure in the field accurately. So this is low speed swept path, that's what we're looking at now. So here are the same rainbow charts, and again we want smaller charts the better. We want to take up as little road space as possible, and we want the vehicles to be better than the road trains, but in this case those horizontal black lines represent the A double performance, and the A doubles perform better in terms of turning around tight intersections. And I guess this was expected, as I explained earlier about the A-type couplings. There are more A-type couplings and more articulation points, so the A double vehicles do perform better in this standard. But the idea was to also look at the level 3 performance. It's not as good as a road train, but is it acceptable for the road train network? So I'll illustrate that in the next couple of slides. You can also see it's worth pointing out that there's not much difference in low-speed swept path between the different freight types, but there's more variability between the freight types. So the key internal dimensions can affect performance quite significantly. Just to prove that point, if you just have a look at the low-density example, so the light green color compared to the black line in the same low-density group, there's quite a difference, almost a difference of a meter between their performance. So now I'll talk about the 36.5 meter concept versus the 35 meter concept. I touched on that before without properly really explaining it as well as I could have. B-triples can go to 36.5 meters, but there was a bit of intelligence before this project started about understanding the limits of these B-triple combinations, and it was known that they might not perform well in this low-speed performance maneuver, and a way of addressing that was to shorten them. So the idea was to look at vehicles perhaps less than 36.5, 35, 34, 33, what would be the maximum length really that the vehicles could be and still pass the low-speed swept performance. Now, here's two identical vehicles as far as I can tell. People believe these to be identical. They look identical to me, 36.4 meters each. But when we start to look at the internal dimensions, we can see that there are some differences. So I've labelled vehicle 1 as having long wheelbases generally. Wheelbases or S dimensions. Wheelbases refer to dimension between the wheels and the prime mover, 5.2 compared to 4.8. S dimension is the 8.75. S dimension is the wheelbase of a trailer compared to 8.38, and then for the rear it's 9.5 compared to 9.1. So vehicle 1 has longer wheelbases. But then vehicle 2 has a longer rear overhang, 3.2 compared to 2.8. It also has a longer fifth wheel position, so the fifth wheel is set back 0.73 meters compared to 0.2. So it's interesting to think what effect this might have on low-speed swept path performance. And let's have a look what effect it does have. You should see a scatter chart now. These are all the B-triples represented on a chart that shows their overall length along the x-axis and their swept path performance along the y-axis. And this is the difference between level 3 and level 4. Now remember, the road train network that we're targeting is level 3, so we want all the dots below level 3. And we can see that there are two sticking above level 3 in the level 4 category, which means they won't have access to the A-double network. Now, there are 3 dots in this range up here at 36.5 meters. So I'm going to ask you now, for a show of hands, which vehicle do you think is the highest dot, the one which has the worst low-speed swept path performance? Do you think it's the one that has the long wheelbases or the one that has a long rear overhang? So I'll say, show your hand if you think it's the long wheelbase alternative vehicle 1 that is the worst performing. So,
all right, we're just
Angela,
waiting.
Maybe help me out and help you with this show of hands.
Yeah, okay, well, it's looking like maybe a third of people have raised their hand. What does that sort of say to you, Anthony?
How many people have voted? I can't see any hands at the moment, but maybe I'm just looking at the wrong.
Oh, no, that's all right. I can see about a third of people have raised their hand.
Yeah, I can see the hands going up.
So what does that sort of say to you, 1/3 of the audience?
Well, it's a bit of a tricky question because I was hoping for more hands, so maybe more people are still making their mind up.
All right, so that's the hint, people. You can raise your hand now. Fabulous. Actually,
I'll reveal the answer now. So.
Okay, and just after you do so, we've had a couple of questions, so we'll maybe answer those after you reveal the answer.
Mm-hmm. Okay, so there you can see that it's actually the long wheelbase alternative that is the worst performing vehicle. But why I showed this and I included this is that vehicles that have the same overall length can straddle the line of being level 3 or level 4. So if a policy is trying to put in place a length limit of 36.5 meters, it's not sufficient to say that the vehicle will be guaranteed level 3 performance. So I guess the way of working around that was to say let's cut it back to 35 metres, get away from that grey area where we're not sure if vehicles will pass or fail at 36.5 metres, and it was a good approach, I felt. Okay. Now we also did a little bit of work to better understand how the sensitivity of these internal dimensions, and we've made a few changes here. We increased the rear overhang by 0.6 of a metre, increased and decreased. We decreased the front overhang by half a metre. We also changed the wheelbases for both the front and rear trailer. And now I'm really enjoying this interaction, so I'm going to ask the question again. And last time we had a 50-50 chance of getting it right. This time you've got a choice of 4. So the poll will open again. Which of these 4 changes do you think will have the greatest effect on vehicle performance?
Okay, I've launched that now, so everyone should see that up on their screen. And if you can get your answers in, that would be fabulous. We've got about 25% of people have voted, so we might just leave that open for a few more seconds. Alrighty, it looks like answer D is winning at the moment with the highest percentage, but I might just leave it open for another second and closing that off now. So I'll just share those results with everybody. Anthony, can you see those on your screen?
Mm-hmm.
Answer D wins.
We have the majority answering answer D. Now I just won't reveal what they are until we step through the next couple of slides. So let's have a look again at our scatter plot. And this is our starting point. Can everyone see a 34 metre grey dot right in the middle? That's our starting point. That's before we made any of those modifications. And now let's make those modifications and see what effect it had on the low speed swept path. So we've added 0.6 of a metre and taken away 0.6 of a metre. So you can see those 2 red dots have moved left and right on the chart because the overall length has changed by changing the rear overhang. The low speed swept path has not changed at all. So I'm sorry for the 21% of you that said that it was rear overhang. And probably before doing the study I might have been tempted to answer that myself. But that means that the cornermost points of the vehicle, the points of the vehicle that draw the swept path, the extremities, aren't affected by rear overhang. So it's the front corner of the vehicle perhaps, but maybe a point somewhere along the inside of the vehicle that's taking up the majority of the road space. So rear overhang between these limits doesn't have an effect. Actually no change whatsoever. So let's have a look at front overhang. Front overhang has decreased by half a metre, and so has the low speed swept path. Not by half a metre, but by something like about 0.3 of a metre or 0.4 of a metre. So that has had a large effect. Now the question is, does wheelbase have a greater effect than that? And I'll reveal both, and it is actually the rear trailer that has the greatest effect, just a little bit greater than changing the front wheelbase. So really I would probably say you were pretty close if you picked the front trailer, and 50% if you picked the rear trailer, so it's correct, we do have a very learned audience with us today. So yeah, wheelbase has a big effect. That's the finding out of that sensitivity analysis. And again, there's the margin for level 3 and level 4. Okay, and the last measure that I'll take you through today is static rollover threshold. It's arguably the most important one because it has the best or the closest correlation between performance in this measure and the risk of having a rollover or a crash on the road. Rollover threshold is the tipping point of the vehicle, at what point the vehicle will roll over going around a curve. And it's one rule for all vehicles. There aren't levels of performance here. It's a pass or a fail. You have to achieve a level of 0.35 G, which is an lateral acceleration of 0.35 G before the vehicle tips over. And for dangerous goods, we set the bar a little bit higher. We set that at 0.4 G. So just to give people an understanding of what 0.35 G is, it's if you're a Formula 1 driver, you'd probably be experiencing regularly about 1 G of force. So this is about 30% or 40% of that. Now trucks don't as low and they don't handle like Formula 1 cars. to give you a bit more of an insight, a funny story that I always remember is that I was told, I'm not a smoker so I can't be sure about this, but when you go around a corner your cigarette packet slides across the dashboard at about 0.2 G. So 0.35, really you'd be feeling that, and it's quite a high level of performance that we're looking for here. So here are the results. I've put in the threshold for pass and fail there at 0.35, and we're looking at the vehicles by category again, and there's a big variability in the different types of payloads, which is very interesting, but the dimensions don't make much of a difference. The differences between the different colors in the groups are relatively the same, but a big difference between the low density and the high density bulk products, which if you think about for a second does make sense. Low density product is grain. So an example of a grain truck might be something that's filled all the way to the very top. If you've ever seen a Bark King vehicle going around, it's all the way up to 4.3 meters, very high. So it has a very high center of gravity, which means it's more likely to roll over compared to something like a vehicle carrying soil. It's going to have a very low bin height and a very low center of gravity, so it'll perform quite well. So there's a difference between those two products. The other point to note is that the tankers perform very well, and they actually perform all above 0.4, which is a good thing, because amongst those tankers there probably are some dangerous goods vehicles. Some might be carrying milk, some might be carrying diesel, some might be carrying fuel. So they all are above the 0.4, which is a good result. And the livestock vehicles are actually below that 0.35 threshold. Now livestock vehicles have quite a difficult load. It's a live load, a moving load, 2 decks of cattle is what we simulated here, and it's below the threshold. But it's also below the threshold for the A doubles. So when you compare like for like, the B triple livestock vehicles perform better than the A double counterparts. And in fact, if you look across the board, the horizontal lines that represent the reference road train are all below the coloured bar charts for the B-triples. And as opposed to the previous results, the higher the bar charts, the better. So B-triples perform well. And again, that has to do with that roll coupling between the units. Because when you're trying to roll over a B-triple, the entire unit is roll coupled. You have to roll over every single unit. The prime mover, 2 lead trailers and the rear trailer will all go over as one. So there's a lot of tyres, stiff suspensions, all working towards keeping that vehicle upright. Whereas with the road train, the rear trailer can go over on its own. So it's more likely that the single unit will roll over. Okay, so the results summary. Modular B-triples up to that 35-metre length in general offer similar or improved performance in comparison to the A-doubles, except in some cases which we found to be the low-speed swept path. But generally perform at least in accordance with the PBS, with level 3 of the PBS scheme. So the outcome was we set this is our prescriptive modular set of requirements. So the maximum length is set to 35 metres. It includes full bar and any other fittings, and you must have a long vehicle sign. The mass limits were 82.5 and 84.5, and something that I didn't touch on in this, but we also looked at the maximum engine power that was required to move 82.5 tonnes and 84.5 tonnes safely. So that was 500 horsepower, no less than 500, and also you needed to get a rating from the manufacturer that it was capable of starting on 10% and maintaining gradability on 12. That should read 12.9%. Sorry about that typo there. And then also capable of maintaining 70 kilometers per hour and 1% grade. So you need to match the right engine for the B-triple vehicle, but most operators will be doing that anyway. There's no way they'd be going with an underperforming engine. And the outcome. Ministers agreed to adopt this single national modular B-triple specification, which has enabled modular B-triples to have access to the current road train network, which is based on the A-double road train network. And there's a letter there from the Mayor, I believe, or from the Mayor's office, and it's a direct quote from that is, "This is a significant productivity enhancement for the heavy vehicle sector." So I'll stop here. That's the end of the webinar, and I'll take questions again. I can see plenty are coming through. And there's also some links here that link to the documents if you need some more information. The actual report produced by the NTC, the fact sheet, which is a shorter version of that, Scotty Communique, and then also New South Wales have some great documents there about how to put a vehicle on the road, the notices and permits that apply, and their interactive mapping system. So thank you, everybody. There are my details. If you have any questions, you can call and send it through an email, but I'll also do my best to answer the questions that are coming through on the screen. So thanks again, everyone.
Sorry, Anthony, I'll just take this moment to also let people know that if you are interested in detailed training on freight and heavy vehicles, we do run a 2-day workshop on the topic, and we're actually running one in Sydney next month. So if anyone wants to come along to that, please do let us know. We might get to those questions now, Anthony, if you're ready.
Okay. The questions that are coming through, I think David Coonan's highlighted the significant improvement on livestock vehicles, and it's true there was quite a big difference between the performance there between the two. Someone has commented about about the increased mass that can be carried by a B-double. Can a B-double be loaded to 82 tonnes? A B-double, as far as I know, with triaxle groups, that is about 68 to 68.5 tonnes, depending if you have Euro 4 specs on your prime mover. So there is quite a significant increase to get to 82.5. But it is a valid question and worth pointing out that B-triples only suit some operators, and really it's more suited to low-density products, people that move general freight or light goods are probably more likely to use 2 lead trailers and a full trailer as part of a B-triple combination.
Oh, okay, we're getting a number of questions through now. Ladies and gentlemen, if we don't get to your question today, you can always follow up with us after the webinar and we'll happily discuss your questions with you. We have one here from Vincent. Thank you, Vincent. Would a steerable dolly on an A-double improve its performance in regards to the standards you mentioned?
Yeah, very good question, and it would. A steerable dolly, all steerable axles, I believe, should be used for improving low-speed performance and not necessarily used for improving high-speed performance to pass particular PBS standards. Steerable axles improve the manoeuvrability of a vehicle. It's particularly important for B-triples and B-doubles to have steerable axles because you can see that that's their weakness in their performance. An A-double is already performing pretty well in low-speed manoeuvrability, so I wouldn't suggest that steerable axles are required. The steerable dollies that are out there are usually about improving lane change performance. I think the jury's still out on whether they do that or not. I can also see some technical questions about the modelling capabilities that are coming through. Without spending too much time describing our processes, it's important to remember that it's a like-for-like comparison. So whatever assumptions were made about all the components that go into a vehicle model, such as the couplings and the flexibility of the chassis, the assumptions that were made were the same for the B-triple and the A-double. So it was a like-for-like comparison.
Okay, thanks for that, Anthony. If anyone else has any last-minute questions I'd like to get through before we conclude the webinar, please do. As I mentioned earlier, we have recorded this webinar and we'll be sending the link out to yourselves so you can view it again at a later date if you wish. Anthony, we have another question or a comment from John Lambert.
Yeah, there are a few more questions there about the vertical play and so on in the jaws. They're all quite technical questions, but as I said, the assumptions made between these components of the vehicles, it wasn't particular to any brand or anything like that. It was all about components that were representative of these vehicles. And also an interesting question from Sarah about the B-triple trial on the Hume Highway. B-triples have been operating on the Hume Highway under a trial, in Victoria between Ford Plant and Broadmeadows. I think the question there is about the PBS scheme as well, or whether or not vehicles operating in the trial need to be assessed against the performance-based standards. If I'm repeating the question correctly there, Sarah. I think that vehicles that are up to 36.5 metres would still require to be assessed against PBS, because we've only shown that up to 35 metres in length the vehicles can be guaranteed to be compliant with the PBS standards, or a standard of performance equivalent to an A-double network. So if the vehicle is up to 36.5 metres, I think it still should go through the PBS assessment scheme. But the question about whether the Hume Highway could accept vehicles that are 36.5 metres is probably another question entirely, and perhaps if the route was assessed, it might prove that the vehicle was suitable, because really the limitations of the 36.5 metre vehicle have all got to do with manoeuvrability, and I don't think there's much manoeuvrability required on the Hume Highway apart from truck stops and fuel stops, and if all those facilities are suitable for accommodating B-triples, then there's no reason why they can't operate on the Hume Highway in the future.
All right, we might just take this last question from David before we close up for the day. Is that okay?
Yeah, just to confirm, it's true that 35 metre B-triples do not need a PBS assessment. They can operate under this modular B-triple policy, which is the outcome of this project, which is an excellent outcome for everybody involved in the project, but also industry, because they will be able to reap the benefits of operating high productivity, efficient freight vehicles.
Fabulous. Well, thank you everyone for your participation today. We like an active audience, and Anthony's details are up there on the screen, and we'll be sending those to you later on also. So if you have any further questions or would like to have a chat with him privately, you're most welcome to get in touch with us anytime. So I'll take this moment to thank Anthony for his time today and presenting for us. We're very happy to have you present for us today and working with you again in future. So thank you everyone for your time, and Anthony, if there's nothing more to add, I might just close up.
Thanks everybody for your attendance, and thanks Angela for moderating today. Great job.
Cheers. Goodbye everyone.